In this video, we're going to simplify expressions with square root. The first thing we need to understand is the following. If I am adding expressions containing the same radicand, the radicand is the number under the radical. This is the radical, the symbol. So if I am adding like radicand, I can factor out the square root of 3, and then I will have 2 plus 3 here, and all this simplifies to 5 square root of 3. What I have done, I have used distribution in the opposite direction. So we have AB plus C equal AB plus AC. What I did, I used the distribution in this direction to factor. However, if we have 2 square root of 2 plus 3 square root of 3, these and these are different. We cannot factor as we did here, and therefore this cannot be simplified. The second thing to understand as well is the square root. What is the square root anyway? The square root of a number to the power 2 is equal to x. X positive or 0. Let's take some examples. The square root of 4. 4 can be written as 2 power 2. That gives me 2. The square root of 36. 36 can be written as 6 power 2. That gives me 6. And so on. Just another example. The square root of 100 is equal to the square root of 100 is 10 to the power 2 is equal to 10. Now, 4, 36, 100 are called perfect square. The list of perfect square is as follows: 0, 1, 4, 9, 25, 36, and so on. Why? Because 0 is equal to 0 power 2. 1 is 1 power 2. 4 is 2 power 2. 9 is 3 power 2. 25 is 5 power 2. Now we forgot the 16 goes here as well. 16 is 4 power 2, and so on. Now in part A here, we need to simplify the expression, and when we look at it, it has different radicand: 125 here, 2 here, 32 here, and 20. So what we need to do is to write this radicand as a product of perfect squares. Now the square root 2 cannot be simplified. So 125, 32, and 20. Now 125, 32, 20. What we are going to do is to express them as a product of prime numbers. Now prime numbers are 2, 3, 5, 7, 11, and so on. Now a prime number, it's a number that has got only 2 factors, 1 and itself. Okay, let's start. 125, now we always start by the smallest number, 2. 125 is not divisible by 2, is not divisible by 3. It's divisible by 5. And it's equal to 525. And then we continue, yeah? 5. 25, it's 5 times 5. Finished, we cannot do any more. 5 times 5, this is 5 power 2. It's a perfect square, which is good for us. That's what we're looking for. Now 32 is divisible by 2, yes. 16 is divisible by 2, yes. It's 2 times 8. 8 is divisible by 2, yes. And then 2 by 2 by 2 by 2 and by 2, and that gives me 2 to the power 5. Better, let's write it as 2 power 2 times 2 power 2 times 2. Why? Because we need perfect squares. Good, let's go to 20. 20 divisible by 2, yes. 10 divisible by 2, yes. Make a perfect square. 5. Good, so now this is the expression we have to simplify. Remember part A? So what we need to do next is to substitute each number 125 by what we found here. Let's underline it. 5 power 2, a perfect square, times 5. Now this cannot be simplified. Bring it down. 32, remember what we did here? 32 is 2 power 2, 2 power 2, and 2. We are just substituting, and then the 20 is 2 power 2 times 5. That's what we have here. Now we have the square, the perfect square, and the square root. We start simplifying. Now before we do that, we need to remember a rule in the square roots. The square root of a multiplied by b, it is the square root of a multiplied by the square root of b. So I go here and I write this as, now this no change. Here square root power 2 power 2, 2 power 2, square root of 2. Now this here we also split it like this. Now we have the perfect square and the square root. We start simplifying. This gives me 5. This gives me 2. This gives me 2. This gives me square root 2, no change. And this one here gives me 2, square root of 5. Now I have this with the same radicand as this, square root of 5, so I can group 5 minus 2. The factor 5 minus 2 gives me 3. Now here I have 16 in the numerator. Here I have 4. 16 divided by 4, that gives me 4. And then we still have the square root 2 here. Now I have square root 2 here, a square root 2 here. I cannot group them as they are. I need to take this one and put it up in the numerator somehow. So one way to do it is to multiply here by square root of 2 and here by square root of 2. We did not change anything because this is equal to 1. If you multiply anything, a quantity by 1, you don't change it. So 3 square root of 5 plus 3 square root of 2. Now minus 4 square root of 2. I multiply this 4 by this. And then square root 2 by square root of 2. Now let's go here. Square root of 2 by square root of 2 is equal to square root of 2 by 2. 2 multiplied by 2 can be written like this. And then this gives me 2. As simple as this. Simplify. Four divided by 2 gives me 2. And then all this becomes 3 square root of 5. Now they have got the same radicand and I can group them. 3 minus 2 gives me 1. 1 square root 2 is written as square root of 2. And this is the final answer to the expression given in part A. This is the simplified form. Now in part B, we have to simplify 5 square root of 12 and multiplied by this expression here. Now the same idea. Now we have different radicand, 12, 3, 27. So we try to find a common radicand. Now 12. Remember, you take your radicand and you try to express it as the product of prime numbers only. The prime numbers are 2, 3, 5, 7, 11, 13, and so on. So 12 can be divided by 2, so it's 2 times 6. 6 is 2 times 3, and then we stop. We cannot go any further. Now remember, 2 multiplied by 2 can be written as 2 power 2 times 3. Now square root of 3 cannot be simplified anymore. 27 is what? Cannot be divided, is not divisible by 2, it's divisible by 3. So it's 3 times 9. 9 is 3 times 3. So 27 is 3 to the power 2 times 3 here. Good. We go to our expression and then we substitute. So 5 square root of 12. 12 we substitute by 2 power 2, 3. 2 power 2 times 3. Bracket. Minus 6 square root of 3. Minus 2. Now 27. It's a 3 power 2 multiplied by 3. Now we start simplifying. Now there is a small mistake here. 12 is 2 power 2. 2 power 2 and not 2 power 3. Now we start simplifying. This is 5 and then we split here. Remember what we said before? The square root of AB can be written as the product square root of A, square root of B. So this is what we did here. We split and then minus 6 square root of 3 minus 2. Now square root of 3 power 2. I'm splitting using this same idea. A square root of 3. Simplify a little bit more. Square root of 2 power 2, that gives me 2. It's a perfect square. Square root of 3 minus 6 square root of 3 minus 2. 3 power 2, the square of a perfect square, it's a 3. Square 3 here. Now simplify. 5 times 2, 10. 6 square root of 3. Now 2 times 3, 6. These are like radicand, so we can group. All this gives me minus 12 square root of 3, minus 6 and minus 6. You add the factors, or you can do it by factoring if you want. Now 10 multiplied by minus 12, that gives me minus 120. Now square root of 3 multiplied by square root of 3 minus 120. This is square root of 3 power 2. And that gives me minus 120 multiplied by, this gives me 3, it's a perfect square, and the whole gives me 360. This is the final answer. Now we have reviewed quite a few things. As you can see, you don't need much except the factoring with prime numbers and the basic ideas of the square root of a perfect square to simplify these expressions.